Hello. Good afternoon, ladies and gentlemen. Very excited to be with you today. This is Rihan Mansour. I'm the engineering manager of the Language Understanding Service. And I have Ahmed Ashur from the Language Understanding LUIS team here. We are excited to announce a bunch of new capabilities for LUIS today, as well as talking about like the best practices for how to build an effective LUIS model and like a cool bot. We'd like to see more developers onboarding to our platform. So this is the agenda that I'll be covering today. I'll give an overview of the conversational AI tools that we're offering in our group, as well as some customer case studies for people who are like either working with customers or who are developers themselves working on similar case studies. And we're also showing how to add natural language to your bot using the language understanding service, and what's new for build and our best practices. So let's start with an overview of what's a conversational AI system and what is Microsoft doing in that space. So we have a bunch of very well comprehensive integrated tools, including the Microsoft Bot Framework, as well as cognitive services with different cognitive capabilities. So what's a bot? A bot is like any application, or either on like your phone or your desktop, that can make sense of different types of input. So it can take like input in the form of text, speech, or vision. You can pick like an image of your favorite product, and you want your bot to be able to do product search based on that, or maybe relate this to other products and so forth. And like our bot framework is offering a bunch of channels, including first-party channels like Cortana and Teams, and third-party channels including Skype and Kik and others. So that input coming through these channels should be processed by some bot intelligence. And cognitive services is the rest of the offering that has a bunch of those tools that would help you a lot with making sense of that input, analyze it in a format that your computer can understand and take action based on that. So you look at the cognitive capabilities provided to help you with building bots. You can see like starting from language understanding, analyzing the natural language, to understanding speech, and maybe answering question answers and indexing some of those question answers. Machine translation to enable you, your bot to speak in different languages, as well as some search capabilities and dialogue management capabilities. Once you once your bot makes sense of the input in different formats, now it can take action and link that action to your business logic and to your infrastructure in your enterprise. Like all of the Azure storages and your knowledge bases. And all this solution stack is supported by all of the Azure capabilities for doing security, for doing monitoring and logging, App Insights, VNets, and like all the Azure capabilities. So the fact that our stack is completely offered on the cloud allows you to build enterprise-grade scalable solutions using the bot framework and cognitive services. So today I'll be focusing more on the language understanding capabilities, the LUIS part, as well as the dispatch part of your bot. So imagine your bot is handling questions that can be either handed off to your backend to be answered. Like, for example, if you're building an HR bot and you want to get an answer for like, what's my sick leave balance? This is something that the enterprise infrastructure would be handling. Versus maybe what's the sick leave policy in my company, which is more of a frequently asked question. So we'd like to see how to use LUIS to dispatch between these different types of questions that could be answered with different parts of your enterprise infrastructure. These are like the key differentiators for our conversational AI offering within Microsoft. We're offering a full bot life cycle integrated with Azure, as I mentioned. So we offer a code-first approach, ranging from the SDK, like the bot framework SDK v3 and the v4 that is in preview now, as well as a bunch of command line tools that we announced in build this year, to help you manage your bot assets easily in one place, as well as like the UI interface, the easy portal in Lewis and Q&A Maker and other cognitive services that can help you build your custom models in a very easy way, even without having a lot of background in machine learning. We also have like all the enterprise grade level SLA, and almost all our services are G8. And we have a bunch of compliance standards that we announced today. We are GDPR compliant, as well as ISO and HIPAA compliant. So we work across different compliance stacks to help you across different industries. Lewis also offers the power of customization with very little effort. So in the past, people used to build like those language understanding models in tens and entities with a lot of expertise in machine learning. You need to get data, as well as you need to get the right expertise in your org so that you can build these models. Today, we give you that very easy interface in the language understanding service to leverage the power of machine learning, but without having to have a lot of background in machine learning, even no machine learning background at all. But we still can like help you customize and build the model that your domain and your specific bot is targeting. So this is exactly like a key differentiator here, the power of machine learning without with very little effort. And we also announcing a bunch of like capabilities around using machine translation to enable you to build your language understanding and Q&A Maker models once, but your bot would be able to like talk in different languages and detect the user language and be able to like respond in that same language in multiple countries. These are some of our customer case studies that probably some of you would relate to a lot. We have more than like 1,000 plus companies using our frameworks. All across the globe, as you can see, in different verticals. You can see people using us in finance, in telco, and in insurance, in health, and so forth. I'll be focusing maybe on a couple of those customer case studies, and I'd like to get maybe some questions at the end, for the case studies that you relate to, or would like to hear more from the partners that you're working with, and so forth. Telefonica Aura. Telefonica is a leading telco company in Spain. And it's available in like different countries, like Argentina and like Brazil and other places. They announced their Aura Assistant back in February, in the second half of February this year, in 2018. And they have been building that virtual assistant that can help you answer and interact for some questions like, what are your recommendations for what I watched tonight in terms of movies and so forth? And Aura would be able to answer such a question and make recommendations that are very specific to your bundles and to your own preferences. Questions like, hey Aura, how much mobile data am I left with? So it's answering questions that are very relevant to you as a user of Telefonica, as well as maybe create a Wi-Fi for my guests. So it helps you with both task completion. As you can see, it enables Wi-Fi for you, which is a task that Aura is completing on your behalf, versus answering some questions. You can see that this kind of virtual assistant has been built on top of the Microsoft Bot framework, as well as language understanding, dispatch, and Q&A Maker. And towards the end, I'll be talking more about a reference architecture that Aura and others have been using for dispatch, so that they can see what kind of questions can be answered using Q&A Maker versus questions that need to be answered specific to you as a user of Aura. The second use case is a smart retail use case. It's Dixon's car phone. And Dixon's is an electronics retailer that has been building that car phone bot. And it tries to interact with customers who are interested in their products, even before coming to the store. So people want to do product search, so they indexed all the products with all the specs and pictures of those products. And they integrate with a wish list for each individual customer, as well as hand off to humans when needed. And this thing has been like launched in 11 countries. So you can see like it's quite a big system. And also there is the seamless online and in-store experience. So like their staff has been trained on a bunch of frequently asked questions from their customers. And those agents have been able to index those frequently asked questions in our Q&A maker tool. So that like now your in-store experience is very similar to the bot experience. So this is kind of like a typical architecture many of our customers have been following. If you can see here from the sequence of numbers, you get a message in number one through a channel from a user, right? Somebody who's doing a product search, for example, for a mouse. And then this passes through one of our channels, and then the second stage is being passed to all of a bunch of cognitive services that would make sense of that input. So you're getting a natural language input like, find me a mouse, right? And then you're trying to analyze that for user intent and what are the entities. So this is a find product intent and a bunch of entities like wireless mouse, right? And then the bot is trying to make sense of that and deciding accordingly to where to forward that question and get an answer, right? So it forwards this to its backend so that it can get like that product and maybe related products. And it's using maybe search capabilities from Bing Custom Search and so forth from cognitive services. And then for those frequently asked questions, you can see that some of those questions are being forwarded to their like backend of knowledge stores that have answers for policy questions, returns, and refunds, and so forth. And this is kind of like the typical architecture that we see with many customers. So now, how do you add like natural language to your bot? So the language understanding service, LUIS, is our offering that we're focusing on today in this session, so that we can like show you how you can add those capabilities to your bot. So what is the problem we're trying to solve in language understanding? What do we mean here by, what is the problem that LUIS is helping you with? Assume you're getting that query or like that user input. So find me a wireless mouse at $30, right? Or less than $30. So this natural language query is very hard to make sense of and take an action upon if we don't analyze it in a way that our machines can understand. So maybe one format that our machines can understand is the JSON format, right? So maybe I want some analysis of that query into some JSON format that I can make sense of. And so I first off start by identifying what's the intent. Maybe I have like within that bot multiple intents, like maybe find an item, buy an item, or add it to my cart, or maybe return it, and so forth. So I might have maybe 50, 60 intents. I want to differentiate between those. And then I want to also identify, it's not enough to get the intent, because what if it's only finding an item? What item should I find, right? I need to know that piece of information. So here, for example, I want to find a wireless mouse, and there's a price there. And actually, it just happens that that price is a composite of maybe a number and a currency, right, that I need to understand. So there are some details when I'm even trying to understand and make sense of the entities in that natural language query. So LUIS is exactly meant for that. Given that input, I want to get that output. And maybe for some types of entities, I might be interested to get some sort of a resolution. Like think of date time. If I'm saying I want a mouse before next week, so next week is relative to where I'm talking today, right? So the machine has to make sense and return to me not only that it's next week, but also that it's like a date for that. So it translates, it detects next week as a date time and puts next week as relative to my current date so that like it's a specific date, right? So I like sometimes to get even resolution in addition to the decomposition of the entities I'm showing here. So what is LUIS? So LUIS is a cloud-based bunch of REST APIs on top of the cloud that allows you to build custom language understanding models that can, given some natural language query, provide you with some analysis to that query, right? But it's very specific to your bot. You can customize. We give you a bunch of tools to get started quickly. We might give you a bunch of pre-built applications, but at the end, you have full power on top of that to make control over your application. So it allows you to add natural language to your applications. It uses machine learning across the board. It leverages all the machine learning technology in Azure Machine Learning and other products in the company that are the best, one of the best in the world. And we are also allowing you to start quickly. We like you to get started quickly. We don't want you to have a lot of machine learning expertise or a lot of data. When you don't have data and you don't have that expertise, come to LUIS, because that's the right place. So what we're doing here is we help you get started through maybe a bunch of pre-built applications across different domains, like maybe music, assistance, teleco, and so forth. And if you go to our catalog of pre-built applications, you can start there. But it's not enough that you start there, because if I give you an application that we designed even in your own domain, it might not exactly work for your own queries, for your own customers. So we have to still provide you with the power to customize even those pre-built apps. So we offer our pre-built apps in a way that you can customize them. We offer you a bunch of pre-built entities, like date time, like numbers, like currency, those ones that are commonly used among our customers and across different domains, right? So you started early, but you built your model, but now your bot has started getting some traffic. And based on the behavior, typically people start with their bots having a certain view of the world about their customers or their end users. But over time, users tend to send specific queries to the bot that might make the owner of the bot change how he looks or she looks to that. So you have to give you some capability to improve your application, your LUIS application, and your language understanding capabilities in the bot to adapt to the real traffic. And we do this through a lot of intelligence from the machine learning world using active learning and other techniques that help us guide you through which utterances, which sentences that you need to add to your application and retrain your application based on from the real traffic. So assume your endpoint is getting millions of endpoint hits. Would you sit and label those millions to improve your model? Probably this is not what we're looking for. We'd like to offer you more. I would like to offer you a way to selectively pick the ones that would make a difference in your application. Because we can see your training data, and we can see how your model is performing. We make the proper suggestions for you, so you end up maybe labeling few tens, and you see the improvement you're looking for. So this is kind of like the feedback loop that people tend to improve their bots through over time. And finally, this is, as I mentioned, an enterprise-ready, available worldwide. We're in many regions, in many languages. I'll be talking about this among the capabilities we're announcing today. So what's new in LUIS for Build? This is the exciting part. So we have features announced in 3 major categories. We have today, I'm very excited to announce our integrated experience between LUIS and other cognitive services that are very relevant to LUIS. So in the past, people have been trying to use LUIS for the text part, but they always wanted their bots to be able to interact with their customers in speech or in language, right? You can text or talk to your bot. And today, we're announcing a full integration between the LUIS and the speech services in cognitive services using one key, only one key that you fetch from Ibiza. And now you can have that key in your bot, and you can either talk or text to your bot, right? And LUIS, not only that, that integration allows for the speech customization based on your LUIS training data. So you've built your LUIS model with a lot of data, right? Now you want your speech to automatically understand that and build a custom speech model. So we give you the full power of customization, both across LUIS and speech, through the sending the LUIS data to the speech service and make use of it, only by making one check mark at publishing time in LUIS. Enable speech. You only enable speech. One key and you're done. Not only that, we also integrate with the text analytics capabilities in cognitive services. So text analytics today is offering key phrases as well as sentiment analysis. So LUIS today, with only another click of a button, you can get the sentiment at the endpoint. So you're now getting intents, entities, and sentiment at your endpoint for LUIS. And for key phrases, this is a new type of rebuilt entity. So what are key phrases? Key phrases are kind of a noun phrases, like, what's my sick leave policy? In the past, I would like to detect sick leave policy as an entity. So I used to provide a lot of training data to LUIS so that it detects that noun phrase. Today, text analytics can allow you to do this only by choosing the rebuilt entity of key phrases. And now, all these noun phrases will be detected in your application. So this capability is now in LUIS. And also, we have that new preview feature in SDK v4 in the bot framework for machine translation. So we're using machine translation capabilities, 60+ languages today, to allow you to build your LUIS model once and enable machine translation with few lines of code that we will be showing you in our demo, so that you can now have your bot speak in those 60+ languages. So this is like kind of our integrated experience story. The second group of features are related to our core language understanding. So LUIS has always been promising the best quality of language understanding, the best analysis of very complex queries, the most comprehensive set of entity types that we can offer. So we're offering patterns. What are patterns? Patterns are kind of token-based regular expressions that a lot of people used to use in the past to detect intents. So for example, think of a travel bot. I want to travel from somewhere to somewhere. This is kind of a linguistic pattern with only some placeholders of the origin and destination cities, right? So in LUIS today, you do this by providing a bunch of utterances to train LUIS on that pattern. We're giving you that capability. We allow you to only provide that pattern instead of providing a bunch of those utterances of the same pattern that follow that same pattern. And we integrate this fully with the machine learning. So it's not only that rule-based thing, but also a hybrid system that can make sense of your patterns to save you effort, as well as like leverage the power of machine learning with that. So our new pattern feature would save your effort to make the language understanding experience much more comprehensive. And now we're also offering a bunch of new entities, like regular expression entities. So now you have a character-based regular expression entity for maybe your credit card number or your social security number and so forth, if you're trying to detect that in your bot, as well as the key phrase entity from text analytics. And the third bucket is the enterprise-grade service. We announced our GA back in December 2017, both the language understanding service and the bot framework. And today, actually, Q&A Maker, which is very close to the bot building tools, has announced its GA in build. As well as like our availability worldwide. So we're available in 12 languages and 13 Azure regions. So we're almost all over the globe. You can use us from anywhere, right? Literally, we're all over the globe. And as I mentioned earlier, we're compliant with a bunch of those compliance stacks, especially GDPR, data retention is we're taking this very seriously, like the rest of cognitive services and bot framework. I think Microsoft is still keeping its commitment to like privacy and all the data retention policies. So now it's time for demo and see these capabilities live. So Ahmed on the LUIS team would be showing you this.
Hello, everyone. Hello, everyone. My name is Ahmed Ashur. I'm a developer on LUIS team. And I'm going to do a little demo. So in our scenario, we're the owners of Contoso, an online, very large retail company with a very customer-obsessed culture. We really appreciate the customer feedback, and we want to work on it. So we want to allow our customers to provide us, or allow them, or give them the capability to provide us with feedback across different channels. And we want to build the solution that would allow customers to inquire about our products and services and so on and so forth. So we want our solution to do basically 4 things. we want to give our customers the ability to provide feedback through our social media networks like Twitter. We want to create a bot that will allow them to do their shopping, track their orders, provide us with feedback, or even contact customer support. And we can deploy this bot to work across different channels, and we've chosen, for the demo purposes, we've chosen Skype. We want to create a speech-enabled intelligent smart app that will allow customers to track their orders using just speech, basically. And we want to create some sort of a dashboard to gather the feedback, or gather some sort of or create a report or some analytics over the feedback that we get from our customers. So I'll show you how the demo works, or how the bot works in Skype. So I've created the bot, I've deployed it to Azure, and I enabled it to the Skype channel. So basically, if I say, hello, hi, I'm shopping your assistant. Well, I am looking for a wireless mouse. So it provides me with the wireless mice that I have in my inventory. And if I say something like, what is the return policy? It gets the response from my policy based on the FAQ document that I provided it to it. And if I say, how long would it take, when am I expected to get my refund? Okay, so basically, that's the bot, and the Power BI chart that we have for the feedback is right there. And if I tell the bot that, thanks for the timely delivery of my Legos, you'll notice that it returns the delivery, others, which is the category for the Legos. I don't actually register Legos as any category. And the feedback is neutral. And if I say, I received my phone in a very nice packaging, okay, so it's delivery for electronics, and the sentiment is positive. So if I go to my feedback chart and I just refresh it, you'll notice that this bar, the electronics bar, increased, and the others bar increased, because the neutral feedback that I received and the positive feedback that I received from the bot. We also allow doing this through Twitter. So if I say, I received my laptop with broken packaging, and I include the hashtag for Contoso, what happens right there is that I've provided, or I created, something that we call the Logic app. The Logic app listens to the Twitter feed, and I told the Logic app to search for the hashtag Contoso. And what it does, when it finds a tweet that has the hashtag Contoso, it sends it to our feedback service, which detects the sentiment for it, and then sends it back to our Power BI chart. But it might take a couple of minutes to do so, so we'll get back to it. So this is the demo, or this is the bot that we have. And so that's the solution that we built. How we built the solution is by using Lewis, Q&A Maker, Bing Custom Search on top of Bot Framework, along with language translation and the text analytics API for sentiment and things like that. And we've also used Power BI to show our metrics. So how did we build a Lewis app to detect all of those actions and respond with the appropriate responses? So we followed the Lewis app dispatch model, where we have a Lewis app that has the top-level intents. And based on which intent gets triggered from the top-level app, we call another specific app with the subcategory of this action that we want to take. So if the top-level intent is shopping, we trigger the app that has add to cart, buy item, or find item. If the top level intent is support, we trigger the app that has track order, connect with a human, or check our privacy policy or return policy, for example, and so on and so forth. So I can actually show you how we built this in Lewis. So in Lewis, I have 4 apps. One of them is called the e-commerce Contoso Master. Yeah, sure. How's this? Is this good?
Bigger. Bigger, make it bigger.
Okay. So we have the e-com Contoso Master, which is the top level app. It is the dispatch app, and it has all of the subcategories of intents that we want to trigger apps for. So we have the feedback intent. If it's triggered, we call the feedback app. It has the greetings intent. When it's triggered, we just return just a simple greeting message. It has the non-intent, which is the all others intent in Lewis. It's a concept that we have that, when you're trying to label different intents, all of the other examples that don't fall in any of these intents, you put it in the non-intent. And we have the shopping intent and a support intent, and each of them triggers the appropriate app. So let's dig deeper in the support app. So in the support app, we have connect to a customer support agent, check our policy, and track our order. Okay? So these are pretty basic, and we want to get some parameters from the users that will allow the customer service agent to better serve them. For example, we want to read the order number if the user provides any, and we want to read the order description if the user doesn't have his order number with him. So we in Lewis right now provide, as Riyam said, 2 different new types of entities that can help us do that. The regex entities and the pattern.any entities. For the regex entities, in our scenario, order numbers are basically 3 characters followed by a dash and then a set of numbers. So we can create an entity called the order number, and if you can see clearly, the regex is 3 letters followed by a dash and then a set of digits. And for our order description, we can either provide, we don't really know what context the user would describe his order in. So we can either provide as many examples as we can to cover the context for order description, or we can just use the pattern.any feature to provide a simple pattern that the users can follow to give us the order description. So basically, I created a couple of patterns. So I actually declared an entity, a pattern entity called the order description, and I provided a couple of patterns that that I can use order description in. So if the user says, I ordered something, 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 and then provides me with a date time, the something, something, something gets translated to an order description. And if the user says any updates on my order of something, it gets translated into an order description. And I've also enabled sentiment analysis in this app. So if we say something like any updates on my order of a wireless mouse and keyboard bundle, order number ABC-12345. If we check the top scoring intent, it is a track order because it follows this pattern, and this pattern is associated with the track order intent. The entities detected are order number because it follows the regex 3 letters, dash, and numbers. And the order description is a wireless mouse and keyboard bundle order number ABC-1234 because it follows this pattern. So, and the sentiment that I get from this statement is neutral. I don't get any sentiment. So if I say something like, I really like this headset, for example. So I get a positive sentiment for that. So that's how you build the Lewis model to leverage all of the new features that we have to get you to do what you do. And so we're going to dig deeper in how the bot is implemented. Let me know if you can see this.
Make it bigger.
Is this OK?
Bigger. Dimension.
Okay, let me just. Is this OK? OK. So the main dialogue that we have is called the root dialogue. That's the entry point of our app. And Lewis is used as kind of the thing that governs the control flow of this bot. So depending on the intents and entities that we get from Lewis, we take the next action, or we tell the bot to take the next action. So initially what we get is we ask, we get the input from the user. We translate it if it's not in English because we built our model in English. But this doesn't mean that we only have to use the bot in English. We can actually use it in whatever language we want. And I can demonstrate it right now. Like if I say, bonjour. I get the response in French. And how it works is, bonjour gets sent to the bot. The bot detects it's not English. It translates it to English, gets the Lewis intents, and goes through all the path or the flow of the bot. And then when it returns the answer, we translate it back to French because that's the initial language that the user used, and we get it back to the user. So the first thing we do is we translate the text. We detect the language. If it's not English, we translate it. And then we get the top scoring intent in Lewis. That's the sole purpose of the master app that we have. It tells us if the intent is greetings. It tells us if the intent is shopping. And we take a different action based on each intent. So if it's greeting, we just display the greeting message. If it's shopping, we go to the shopping dialog. So what does the shopping dialog do? It actually calls the shopping-specific Lewis model. And depending on the response it gets, if the intent is find item, we take the keyword, the item that we're looking for, the item keyword, and we call Bing custom search. So that's another service that we leverage in our bot. So we have our own, or we built our own warehouse or our own inventory of products, and we've indexed it using Bing Custom Search. So we provide Bing Custom Search with the keyword a wireless mouse, and as you can see, it returned the wireless mouse or a couple of wireless mice that we have in our inventory. And the second dialog that we have is our feedback dialog. So our feedback dialog calls Lewis, and if the intent is delivery, we call our feedback service that uses Stream Analytics to display it into the Power BI service. And if our intent is the support dialog, we also call the support Lewis app. And if the intent is policy, we contact Q&A Maker to get us the response for the policy question that we just got asked. So as you can see, we could incorporate all of these services into just one bot. And it's relatively very easy to build this bot. I actually built this bot in like a day or something with all of the accompanying services and things. So that's actually not everything that we have to show in Lewis. The last thing that I wanted to show you guys is how Lewis gets incorporated with speech. So we offered, or Reham announced that we have some sort of integration between the speech service where you get just to use one SDK, one Lewis key, and it just works, instead of you having to incur the 2 round trips and maintaining 2 different keys to do the whole thing. So I have an executable right here. Okay. So I'm just going to use this. So if I say, hello, so it detects hello, and the intent is greeting, and that's the Lewis response it gets. If I say, I would like to track my order. So it's basically speech plus Lewis combined, which is pretty cool.
For a smart app. For a smart app.
Yeah. So how easy is doing all of the speech and Lewis integration? It's pretty easy actually. So I've just created a very simple WPF app, and all it does is when you press a button, it just calls the API, basically. So in the initialization of the WPF service, I initialized something called the speech to intent client. The speech to intent client, all it does is reads the Lewis key and the Lewis app ID and which endpoint region is this key associated to from the configs. It initializes something called the speech factory and the language model using the Lewis key. And every time I say recognize, it creates something called the intent recognizer from the speech factory. It provides it with the Lewis models, or which intent models we would like to listen for in this Lewis model. So in our case, our Lewis model names are the 5 intents that I have in the app. And then all you have to do is call recognize async, which listens until you stop talking. And when you do, internally it recognizes the speeches or changes the speech to text and then send it to Lewis. And since everything is hosted into Azure right next to each other, the latency is nearly negligible. So it's pretty cool. So that's it for the demo. And we'll be back with Rian.
Yeah. So let me take a deeper look at how to build an effective Lewis application. What are the best practices we've seen across customers and across even like the philosophy behind when we built that project? So this is kind of the development life cycle for Lewis. You need to you need to go in cycles. You cannot build a language model that is like doing what you want from the very first shot. So it's a very iterative model following the typical software engineering process for developing any kind of service or product. So you start off in the planning for your Lewis application. And when you plan your Lewis application, it means that you need to define your schema. You need to define what intents and what entities would exist in your application. What kind of intents that you want to differentiate between, right? And what kind of parameters are important for you to be able to take actions based on detecting these intents. But maybe you can start off, like our recommendation is that you start off by the intents that you know of. You don't have to start with so many intents at first. The ones that you're sure that your bot has to handle, you can start off with those. And you can keep adding in the future because we give you a very smooth path to improve your application. But then once you defined and you planned your schema, now you start adding a few training examples to every model. So you start adding examples for intents and for entities. And you have to add few examples. And by few, we mean like few tens. I would say I would start with 10, 15 examples for every model. I don't recommend that we start off by so many examples. It's not a training platform on the cloud. It's not. Azure Machine Learning is the training platform on the cloud. Lewis is helping you more doing interactive learning, and it's meant for you when you don't have plenty of data, or when you want to build what we call cost-effective language understanding model. By cost-effective, I mean fewer labels that retains the same accuracy. So in machine learning, like a lot of data could do well, but the right features could help you also. So if we select the right data from your training examples, as well as the right features, probably we can come up with a very what I call a cost-effective model. So that's why we like to go in iterations. And so through your building part, you start by adding examples. Maybe in the first couple of iterations, just add examples and then train and test. But maybe in later cycles, you want to keep improving, right? Until you reach the goal of the accuracy level that you're looking for. And during these iterations, I recommend that you do step 3 and 4. Like you might start adding features or adding patterns. By features, we mean things like phrase lists. In Lewis, there is a concept called phrase list. And a phrase list is basically a dictionary of words that helps you adapt Lewis to your own bot domain vocabulary. So Lewis knows some vocabulary about the word. And it uses that vocabulary to make sense of whatever your examples that you're training with. But in some bot scenarios, your vocabulary might be new to Lewis. And we give you a path to adapt that vocabulary, even without having to know about our vocabulary, right? Through the adding features. And so features could be phrases, could be patterns, and so forth to improve. So I don't recommend that you start off by that from the first couple of iterations. And then in every iteration, make sure that you're using our active learning. So you're making, so don't keep adding data. Just start sending some real traffic to your bot. And then from that real traffic, make use of the intelligence we're offering in Lewis to suggest utterances to label for you. So now, in every iteration, I recommend you add maybe a few other tens, maybe 10, 20, 30 examples for every model that you want to improve. And in Lewis, we give you the capability that you improve individual intents and individual entities. And I'll talk a little bit about that in the philosophy of machine teaching when I come to that. And in every iteration, you have your test set that we allow you to like upload to Lewis in a batch testing, and you see the confusion matrix for those advanced users, or even inspect some elements like what Ahmed was showing on the right pane for testing. And you can like now detect how is Lewis performing on your test set, and you can detect the improvements. And you keep going in iterations as I'm mentioning here. So those are like some of the features that we offer to build models with less effort. So active learning is very key to improve your application based on real traffic. And with few examples. You don't, even if you have like a million examples, don't upload them here. You might need only few hundreds to build a very like well-behaving bunch of intents and entities. As well as like we offer the set of pre-built entities that I talked about, and the pre-built domains like calendar, music, weather, communication, a bunch of those domains that are commonly used among our customers, as well as a way to expand your dictionaries. So we give you a very intelligent technique to expand your dictionaries. So assume you want to build that phrase list that I was just mentioning to adapt Lewis to your own vocabulary. You're not by yourself. You start adding maybe a few entries at first, but then we give you suggestions and recommendations from lists that we mine from the web, from public data, that would help you. So for example, you want to build a cities list, right? You start off by providing maybe a couple of cities, get suggestions, add them to your list, and then refine your search, and you're getting more suggestions, more relevant suggestions, and so forth, until you populate your list. So all these tools are offered to you to build the model with less effort. Now, this is kind of the philosophy that we're taking behind Lewis. So we're taking a machine teaching approach. And what does that mean? How is machine teaching different from machine learning? So this is how we put things. So machine teaching is about providing you as a teacher or as a human with a bunch of tools to extract the knowledge that you know about the world. What is that knowledge? That knowledge is your schema definition, your labels, your features, all what you know about your domain. You're the domain expert. And we're providing you with all the tools to help you express your knowledge about the domain without having to worry about the machine learning knowledge, right? We take care of the machine learning knowledge for you. So this is exactly like the philosophy that we're taking here. And so the machine teaching is about creating useful models from this knowledge, right? From the knowledge that you have, and then give it to the machine learner to extract knowledge out of that data, right? And the two fields are complementary, as you can see. So from an AI quality scorecard, how is Lewis standing? This has been a paper recently released in SIGDIAL of last fall, and done by a team in Munich, a research group in Munich in TUM. And it was comparing Lewis and different conversational AI stacks. So it was comparing Lewis to Watson, like IBM Watson, as well as API.ai or Google Dialogflow, and Rasa.ai, which is another open source bot framework. These are the results coming out of the paper on 4 data sets that were developed by the authors of the paper. And this is kind of like, this is a quote from the paper that Lewis has been always performing the best. And you can see from the results here that for both intents and entities on the 4 data sets, Lewis has been like performing better than the other systems. So Lewis and Watson were close in intent performance, but Lewis was like much better in entities. So Lewis is offering a large collection of machine learning entities. And we're very proud that we're the only one in the competition to offer that. We're offering different types of entities that relate to each other in different ways so that it can help you analyze complex queries. So think of queries like, I want to order 2 pizzas and 3 fries. There are 2 entities here that exist in that sentence, right? But you want to make sure that the 2 goes with the pizzas and the 3 goes with the fries, right? You want to make sure like you're putting the numbers and the items the right way together. So we're giving you different capabilities in our entities, like composite entities, hierarchical entities, for those of you who use Lewis, to model that and be able to analyze those complex queries based on the power of machine learning. So what are the best practices we're offering to you today? One reference architecture that we've seen recurring across different customers, especially for those who are building large-scale bots. That concept of two-layered architecture, where dispatch or the bot language dispatch is a Lewis model that tries to dispatch between the different buckets of actions that the bot is trying to make. So think of that Contoso bot that Ahmed was building. And there are three major functionalities there: the product search, the support, and the delivery, right? And imagine in real world, I'm sure like many of you who are dealing with enterprise customers know that these are different departments within that enterprise. So those models might even be developed by different people within the company, because every department knows its business more, right? And we want to provide that concept of building your bot in components and offering a way to have these different Lewis models interact together in the right way. So this kind of reference architecture is allowing you to first off dispatch between which Q&A maker or Lewis application in your bot that should handle that query. And when we land that application that needs to handle that query, we now need to know more fine-grained things about that query. We need to know like the fine-grained intent or sub-intent, and we want to know more about the entities that exist in that. So that's exactly kind of the reference architecture that we completely recommend to people who are building complex bots. So between dispatch and, in that example, what is my sick leave policy? And we're dispatching between travel, rewards, and leaves. And then, as you can see, I'm double-clicking here on one of the modules. And in that module, those are the dialogues and sub-dialogues that are handling that module. Along with all, of course, the security logging and auditing from Azure. So this is kind of a summary for the do's and don'ts that we would like to recommend to people in the room who are building bots and using Lewis for building their bots. So if you look at our do's, I already mentioned some of that, but this is kind of a summary. You need to define your schema very well. You need to spend time thinking of your schema. And your schema of intent specifically need to be discriminative enough. There are so many questions about such design issues. For example, if I'm creating a bot that is booking flights and hotels, and now I'm between designing my Lewis application with two intents, book a flight versus book an intent. This is one option for designing that. Versus another option of creating one intent, which is booking, and then having hotel and flight being entities, right? And we cannot say like this is right or wrong. I mean, those are two possible designs to solve that problem. But what we can give you as recommendations and guidelines to help you think through that process is, based on the data that you can see from your real users, is it the case that the vocabulary is overlapping between the two intents, book a flight versus book a hotel? If it is the case, then we don't recommend making them like two intents. Your intents have to be very discriminative, or as much discriminative as possible in terms of vocabulary, so that Lewis can be, like, we cannot teach the machine what we cannot do ourselves as humans, right? So if it's hard for us as humans to discriminate based on the vocabulary, then it's hard for the machine as well. So this is kind of like the question that you need to ask yourself: how discriminative are the vocabulary within my intents? And based on that, you can make different decisions, and we provide you with different tools, different types of entities, different types of intents to make that decision. Also, finding the sweet spot between being too generic and too specific in your schema definition. Exactly like back to my example around booking. Should I make it fine-grained, differentiating between like booking a flight versus booking a hotel intents, or making it one generic book intent? I would say that there's always, like, based on the data that you have, there's always that sweet spot between going too generic and too specific. My general guidance in that is you try to model things based on your data. Look at your data. Again, back to the first point. You need to build your app iteratively. There's no way you can avoid that. You need to keep improving your application. Keep a blind test set all the time so that you can see how your application is performing, because you need to improve based on the performance of your application on that test set. Your test set might evolve over time based on the feedback that you're getting on the endpoint based on the real traffic, right? So you need to adapt your test set to reflect the real distribution of your real traffic. Adding phrase lists and patterns in later iterations, as I mentioned. Also, the non-intent. So the non-intent is our kind of default intent, fallback intent, right? What others in the competition are calling fallback intent. So this is kind of the rest of the world. Your world in the bot is maybe the 4 or 5 intents that you created. But then there is the rest of the world, anything else. And that anything else is very important in natural language because it helps you model how the bot would behave if the user goes off the road of the conversation, right? But the non-intent will not behave, like your application will not behave well if you don't feed the non-intent with some training examples. So I would give like maybe a nice heuristic that we learned from customers is that for every 10 positive examples that you provide in total for all your intents, provide 1 example to your non-intent. So very few examples, it's 1 to 10 from the positive examples that you're providing. This is very heuristic, right? It's not like a rule of thumb or anything, just like what we've seen from people building apps on Lewis. Also, you need to leverage our active learning. Don't keep uploading labeled data to Lewis. Just use our smartness and suggestions in Lewis. And monitor the performance using your test set. What you don't need to do is the following. So our don'ts are add plenty of labels. Don't do that. Keep adding iteratively. Few examples. And use Lewis as a training platform. It's not. It's not a training platform on the cloud. It is an interactive learning using few examples to build a good model. And add many examples of the same format, ignoring other formats. What is a format? So Lewis gives you the ability to make sense of the variations of natural language when saying the same thing, when you want to mean the same thing, right? You provide variations, but you still mean the same intent, right? We don't recommend that you provide maybe 5 examples of the same pattern. Book a flight from Berlin to Seattle. Book a flight from Dallas to Seattle, right? Those are exactly the same. Try to diversify the examples that you're providing because Lewis is using machine learning, right? And it has the power to generalize on fewer examples. So use that power. Don't keep like adding examples of the same type. Also, mixing the definitions of intents and entities. So we get that feedback a lot from our customers. So one way to think of intents, map intents to actions that your bot is taking, and map entities to the key parameters to make that action possible. So if, for example, you're making an API call, right, to maybe find a product, right? So find a product would be an API call in your infrastructure, but it needs the product name and maybe the price or quantity of that product that you're looking for. So make those parameters as entities and make that as an intent, the action. This is kind of a rule of thumb, but like there are always exceptions. We can always discuss, back to the define your schema part, we can always discuss different design options for your applications. And create phrase lists with all the possible values. So assume, for example, you want to adapt Lewis to your own vocabulary. And your vocabulary is maybe a bunch of cities, a bunch of airport codes, and so forth. Don't add everything in the world. Lewis can make sense of only a few of those. So if you only provide maybe few examples of those cities in your phrase list or those airport codes, Lewis can generalize because it takes context into consideration. So it gets those words that it adapts to, but it gets also the training examples that have the context, right, that carries the context. And it can make use of both signals to like make sense of what you're saying. Also, adding so many patterns. Patterns are meant to help boost the performance quickly without having to add so many examples. So don't overload the system with so many patterns unnecessarily, because Lewis can still generalize, right? And training and publishing with every single example. So you keep adding one example, train, publish, and test. No, don't do that. Maybe add 10, 15, so that like you see the real improvement, right? So those are like our key takeaways from our customer learning journey and our recommendations. To learn more, get started today on aka.ms/Lewis. And those are some of our conversational AI sessions that relate to this session, and would be very happy tomorrow to see many of you there about bot framework and the command line tools that we're announcing today in Build. And finally, it's time for questions and answers.
Overview on the data security modeling in terms of how you handle the utterances and when the bot administrator looks at the data and improves the learning model, how is the data security handled?
Yeah, so in Build, bot framework, Lewis, and other cognitive services are announced to be GDPR compliant. And our data retention policy keeps the privacy of our customers pretty well. So in Lewis specifically, you have your training data and you have your endpoint hits, right? Or unlabeled data. So for training data, we keep that as long as the developer wants to, and he has full control over his data to view, update, or delete, right? For the endpoint hits, we keep this for 30 days, the 30 days retention policy. And we offer the developers some means to download those logs so that they can learn from it or like process it offline. But then we delete it after 30 days. So this is kind of our data retention policy across the board. More questions?
Question. The code that you showed earlier today, is that available for us to look at on GitHub or some other sorts?
We can definitely make it available on GitHub. It's not as we speak, but after the session, it will be available.
Okay, thank you.
Yeah. George?
Yeah, question. How do you do the, you mentioned not to use it as a training model, but to more of a learning model. Could you explain more about that? How does it, I guess, detect that it didn't figure out the right answer?
You mean for building the training models?
Yeah, you said provide very little examples and let it learn.
Yes.
How does it?
How does it work?
How does that work? Yeah.
Yeah. So in general, the approach we're taking is take examples, train some intent classifiers and entity extractors with like some algorithms that happen to like power also Azure machine learning and Bing and other infrastructure within Microsoft. But then the approach we're taking is that in machine learning, not all the examples are equally informative, right? So you might have a model that is trained with maybe 100 examples. If you end up adding 10 more examples, you might, and your F-score at 100 examples has been, for example, 75%. If you add 10 examples, you might reach 80%, and if you add maybe a couple of hundreds, you might reach that 80%. So what is the difference between the two? Remember when I was talking about the do's and don'ts in Lewis? If you keep adding the same example with the same pattern, you don't diversify your patterns. This is less informative than the more diverse examples. So what we do in Lewis, in the nutshell, is that in our active learning part, where we suggest examples for you to add to improve your model, is we pick the ones that are most informative, the ones that diversify your patterns. And when we do that, the machine learner makes better use of those. So we're using those tricks in machine learning on how to refine your model to be able to use few examples, but still improve the model with a number of points that you would have improved with if you provided examples blindly, just so many examples blindly.
Yeah.
Oh, sure. I mean, we still have time. You can finish your question.
Yeah, one more question. How do you handle like The reason why I'm running a chat bot, the reason why I have to use so many examples is because of grammatical and spelling issues. How do you guys handle that?
If you provide so many examples? Spelling,
Grammar errors cause a lot of problems with the bot.
Yeah. So spelling has been a feature that exists in Lewis a while back, even before build. Did you see the publish page when Ahmed showed the demo? When you publish your Lewis application, there are 3 things you can enable today. You can enable, in the past, you could have enabled only Bing Speller. But today, you can also enable the sentiment and the speech, right? Ahmed, can you get back to that? Yeah. When you enable Bing Spell Checker, what happens is that at the endpoint, we pass the utterance first to Bing Spell Checker, get it corrected, and then process it in Lewis and return a response to you. Yeah, so Bing Spell Checker here, it's only a check mark that you add to your application. And when you do that, we enable you to provide a key from Bing Spell Checker. It's not yet a bundle with Lewis. Hopefully, it would be a bundle soon, like the Lewis and Speech bundle. So it will be only one key, but today you still have to provide a key separate for Bing Spell Checker.
Thank you.
Sure.
Hi, my question is more about how do you classify between machine teaching and learning when you're in the design phase? Because it's sort of like, depending upon your background, it's probably a thin line to distinguish between, okay, this is something that we have to teach and this is something it'll learn.
I don't think you as a developer using our platform has to make that differentiation. I'm just describing or giving a flavor of how we make that differentiation when designing our platform. So the point is we provide, the platform is offering, or like the Lewis platform is offering you a bunch of tools to help extract the knowledge from you. This is my whole point behind machine teaching. But you as a developer can only make use of those tools like the active learning part, like defining your utterances, providing features in the form of phrase lists and patterns. So we only provide you with the tools without having to worry about the part that we use these features and these labels or training data to train an effective model and tune it. We do a lot of work in the background that follow the best practices of machine learning so that we can like tune your model on your behalf, given that you provided your knowledge.
Thank you.
Can you talk a little bit how to deploy to other platforms, the bot, like Facebook or Slack, or how that works?
Yeah, so when you, in the Azure bot service today, when you deploy your bot, you're able in Azure to select the channels that you want to enable for your bot. So during deployment, it's only a matter of selecting those channels while deploying the bot. And it's a very, very simple process when deploying. And once those are enabled, once those channels are enabled, you don't do something specific in your code for that, in your bot code, except if some channels do support maybe some types of adaptive cards that are different from others. So you still need to handle that in your code, but it's only like a matter of selection within Azure portal for the Azure bot service.
Hi, thanks, great session. I'm going to push back on the spelling a bit. The spell checker, for a lot of bots that we do, there's a lot of acronyms, there's a lot of specific terms that are, to a particular industry. So the spell checker usually just messes that up. So how do you deal with that?
I hear you. So, and that's why it's part of our backlog. The same way we enable some customization in our machine translation, in the machine translation library for some words that don't need to be translated, we will enable a way to customize for some words that you don't want to be corrected, right? This is what you're looking for.
Yeah.
This is something we're looking at and working on.
All right, cool, thanks.
Hello. Can you describe a bit more the approach for the structure with how to apply the dispatcher? Because the challenge that we've had was that we've built different Luises, let's say, Luis instances to handle like social knowledge or a specific group of intents. And we're considering putting on top of that like another Luis for orchestration. So I understand that dispatcher is actually there to tackle that challenge. So can you explain a bit more? And the follow-up question is, can you also explain the structure for this? Like you mentioned, main intents and sub-intents. I saw something on the diagram with sub-dialogue. So if you can elaborate on this more.
Yeah, and because we see this as a common pattern across the different bots that people are building, part of the command line tools that we announced that built for the bot framework has been the dispatch tool. So the dispatch tool is a command line tool that, given the Lewis applications in your bot and the Q&A maker applications in your bot, it takes on you just give it pointers to those applications, and then it grabs all the training data out of those and builds a Lewis application automatically on your behalf for the dispatch part. So we're trying to help developers create the dispatch for to dispatch between the different Lewis and Q&A maker applications in your bot. This is one way of doing things, the easiest way. But then there's the other way where people have been following that reference architecture where you come up with, the way I would think about that is I would always think about it from a use case standpoint. So if you want to look at your bot and see how many use cases would your bot handle, right? And then based on that, you decide to maybe create different components to handle that. And for the different functionalities, like in the HR bot, leaves versus rewards versus benefits. And for each of those, you want that Lewis app to be localized to that specific bucket of functionality, right? So that's how you come up with the need for that kind of dispatch. But the tool that we created would help you do this automatically.
Hello, thanks for the session and thanks for the best practice details as well. I have a couple of questions. First question is, we have an internal web application which is not exposed to the clients. And adding this chat box and Q&A becoming public, can we use this for mobile, like using the secure web, or do we need to use with the Microsoft Intune?
So this is a question about the Azure security stack, right? I would say in general, we were able in the past to link with, I haven't tried this myself, but in the past we've been able to link our apps to the different security stacks, even if they're not Azure. And even moving forward, you can see some announcements around some of the cognitive services being able to package it as a container that you can deploy to not only Azure, but maybe to other clouds, right? So in principle, yes, we can link to that, but in details, I haven't done that myself.
Okay. Thank you. And second question is, you did provide a best practices with few examples start with, and when do you think the few examples, count-wise you said 10 or 15, right? Is that a sufficient data to start the training and start the use?
You can start the training even with one example.
Okay.
I mean, in principle, but we recommend that you don't retrain after every single example, because typically one example will not make a huge difference. If you pick 10 or 20 or 30 examples to add, but you select them using our intelligence in the suggestions, that would help you pick the most informative examples that I was referring to, because we do a lot of work in the background to pick those examples, so based on your training data and your features, right? Mm-hmm. So we make some decisions around what to show and offer to you based on that. So if you pick from those informative examples, typically few tens would help you make big jumps of improvements.
Thank you.
Hi. So the examples that you gave, they focused on kind of short phrases. Would it be similarly effective if you gave it like a paragraph of text outside of a bot to recognize entities and things like that?
So Lewis has been designed for conversational utterances with limits of 500 characters sentences. So it's not exactly meant for longer documents. However, the text analytics cognitive service has announced a preview feature in this build around entity extraction and entity linking. So if you check their new capabilities, they have that capability on the longer text.
Hi, how are you? So I have a question here. I'm pretty new for Lewis, but when I use it, I'm kind of looking forward to see the capability, input the training data set in batch instead of right now when I went to that web interface, I need to put my sentences by sentences and one by one, which is not that efficiency. Do you have that solution already over there?
Yeah, that solution has been there for a while. So we offer Lewis both is through the portal, and we offer also all the functionalities in the portal through a bunch of REST APIs. And actually those REST APIs are also packaged in an SDK. So you can either use Lewis through the portal, or use it through the REST APIs, or use it through the SDK. And if you use it through the APIs or the SDK, now you have the capability of uploading batch training data.
Okay, cool. Another question is for identify those entities. And sometimes I saw I have to identify for 1 or 2 words. Is that possible? I identify, let's say, five words as a more complex identity instead of like just single words, like you know.
You mean sequences of products, for example, lists of products or things like that? Or just a sequence of 5 words?
Just sequence of 5 words.
Yeah,
like
so the new capability that we announced today around the patterns, or pattern.any, allows you to do this. So if you have a spanless free text kind of entity that might span 3, 4, 5 words, probably pattern.any is a good choice for your entity type in that sense. Although like nothing would prevent you from modeling this as a machine learning entity that you can provide training examples to detect. But if you want to detect like longer sequences of words for entities, you need to probably provide more examples than usual. I would say for a typical machine learning entity, you would provide maybe 150 to 200 examples. If you want to span this on multiple words, and this is like common across your utterances, probably you would need to go in the order of like maybe 700, 800 utterances to train your model.
Okay, and last question is, does Lewis have some pre-built kind of capability inside? Let's say I didn't even put any my sentences into that system, but I hover this API to some like these examples, it will automatically identify certain entity I chose before.
Would you like to take on that question? Rebuild entities and domains.
Can you guys hear me? Okay. So in Lewis, we have some pre-built domain entities and intents, and we package them in something that we call pre-built apps, pre-built domain apps. They're basically apps that contain common functionalities that people use, and they have some already existing examples, and they're already trained, but we allow you to customize them with your own idea of this domain. So basically, we have a domain like communication. It has all the intents that has to do with communication. It has all the entities that has to do with communication, but you can also customize it with your own examples to fit your own needs if the current pre-built app is not enough for you.
So that functionality is available right now?
It is available since last build.
But it's in preview.
Yeah.
What's the name of that?
It's pre-built domains, so let me show it to you.
Yeah, please do so.
Additionally, we also have a bunch of pre-built entities, only entities, that are commonly used, like numbers, currencies, age, dimensions, phone numbers, and date time. So those are ones that you cannot customize, but they are very high quality models that you can use off the shelf.
Okay.
So Ahmed will show that.
You get to choose the whole domain, if you want the whole intents and entities of this domain.
Okay.
Or you get to add a specific pre-built domain intent or a specific pre-built domain entity.
Yes, you can see here.
Cool. Thank you.
So during the discussion, you mentioned about something called sub-entities. So one of the problems that we have been trying to deal with is once you enter into the conversational flow in designing bots, you can ask a question back to the user, and currently we are just limited to asking one data point to the user. So the user wants to book a flight ticket, so he doesn't specify the destination or the date. So you have to ask for the date, and then you have to ask for the destination separately. But it's not really an elegant experience to ask multiple questions back and forth, and we are looking to see how we can kind of, again, ask one question, like provide the destination and the date, so that in that case, the conversation becomes very difficult to handle in a dialogue experience. So the user can say, provide the response in a single text, or they can provide multi-text options and stuff like that. So whatever you mentioned as sub-entity, is it something related to that, or?
We offer two types of more complex types of entities. We have what we call the hierarchical entities and the composite entities. Hierarchical entities are meant to model the is-a relation between parent and children. So imagine you want to specify, I want to fly from London to Seattle, right? Both London and Seattle are cities, but you want to differentiate between the origin and destination. So the way we model this in Lewis is through a hierarchical entity that is a location that has two children. One is origin and the other is destination. And you label those entities as the children, right? And now you get to provide training examples. And even when your sentence has only one city, like I want to travel, not even traveling, what is the weather in London? You can use the parent, which is the location, to label London, right? So you can mix and match between labeling the parent versus the children for the data. So this is one way of modeling the is-a relation. The other piece of complex entity that we're providing is the composite entity, exactly relevant to the example I mentioned about making a food order. I want to order 2 pizzas and 3 fries. I would make the 2 pizzas as a composite entity that has a number pre-built entity and a food item that I create, right? So now that composite entity happens in 2 locations, and I can make a composite entity a child to a hierarchy. So you can see that from our tools, you can model your entities to really understand very complex queries. Relevant to your, so this is like kind of what we're offering, but back to your question around how to let the user provide multiple entities in the answer, but without enough context. So I would say Lewis today, without a lot of context, would not be understanding those entities if they are machine learned entities. If they are list entities, it can understand it. But we are working on features that would let you accommodate the previous turn's context so that it can make use of that while trying to understand the current utterance. This is something on our roadmap that we're working on.
Thank you. And we also have a booth in the Seattle Convention Center. Actually, both cognitive services, the Lewis, the language division, and the bot framework. So if any of you have any questions, so we're
Please
there.
join us
You can reach
there.
us out.
Thank you.